Hello, everyone, and welcome to Inventing. I'm Lisa Lloyd, and we are streaming live today on LinkedIn and Facebook, or you may be catching us on your favorite podcasting platform. Joining us today is my special guest, Grant Posner, president of 3DMusketeers, a full-service 3D printing facility that specializes in rapid prototyping and providing cost-effective means for testing out your brilliant ideas. Now, I don't know about you, but my favorite part of the invention process is that front end. It's getting under the hood and breaking things up and making them better. And so that's why I'm especially excited about today's show. It's the first time we've had a chance to talk about prototyping, and I'm really passionate about it. So thanks for joining me today, Grant.
Thank you. It's an honor and opportunity. Anytime that we get to share this wonderful world of rapid prototyping and the process behind it, we love to do, because there's so much of it that seems to be clouded in secrecy for no good reason, as far as I'm concerned.
I think it's just scary.
I guess it can be. It's not scary to me anymore, but
I know it's not to you, because look, I mean, just looking, and we can only see a small glimpse of your background there, but I know your entire background is just full of this equipment, and this is your whole life. But I'll tell you, just getting into this stuff and playing around with 3D printing myself, it is very intimidating at first. And you have been very helpful to me in taking away, demystifying that, so to speak. But you know what? I wanted to share with our audience. And in a moment, by the way, folks, we're going to open up the Q&A. So if you want to drop a hi, let me know where you're joining us from, just so I know you can hear me. Hi, Celeste, by the way. Hi, is it Pabon? I love that name.
Pabon.
And Deb, thanks for joining us. Let me know where you're joining us from. That lets me know that you can hear okay. And we'll take your questions in the order in which they are received. No invention question is off limits here. We're going to talk about rapid prototyping today, but if you want to understand patents or licensing, sell sheets, whatever, feel free to drop those questions in as well. Nothing's off limits. Grant, I did really want to start off though with something I saw on LinkedIn. You have a master's degree in business administration, and somehow you ended up in this wacky world of innovation. How does that happen?
I've been a geek my entire life. I've always wanted that ability to take something out of this friggin' noggin and put it into my hands. And I wanted to be an engineer. My life's goal was to always be an engineer, but financially it just wasn't feasible. St. Leo University, got both of my degrees from them, made a phenomenal financial package. So decided, you know what? I'd much rather not have a couple $100,000 in debt and then pursue the engineering thing. Most people don't ever guess that I don't have engineering degrees. But the cool thing is we have a whole list of engineers on staff that can help out as well, where my skills are very much on the business side of things. I can help people get those ideas off the ground. But yeah, as a quasi-engineer, it is a little bit odd to have those business degrees as the back end.
So did you come out of school and go straight into this industry, or did you kind of find your way into it?
I definitely started this industry right when I started at St. Leo's, when I was building my first 3D printer. So 2008. I'm 32.
All right. I'm sorry. Time out. Building your first 3D printer. You didn't buy the 189 version that I have in my
those
background.
Did not exist back in 2008. If you wanted a 3D printer back then, it was made of laser cut wood. It was called the MakerBot Cupcake. And I'm in Florida, and wood and Florida don't mix very well. But the cool thing about most colleges is that they have an IT department. That IT department likely has a dumpster full of electronics. And if you're really nice to them, they'll leave some stuff out for you that you can pull off motors and linear guides and all that. Because back in the day, that was the only way to make a 3D printer. Mm-hmm. You built your first one with wood, or if you had a soldering iron, you could burn plastic out, because you had to first assemble the printer to make it print its own parts to make it better. It's the whole self-replicating machine that is the RepRap project. Wow. But I didn't get all that hardcore serious until about 2012 or so, when we opened up the Object Shop, which was my first 3D printing business, and opened that during my master's degree at St. Leo. Mm-hmm. So kind of went to school loving 3D printers, decided to build one, and yep, here we are.
It's funny that you had a passion for engineering. When I was growing up, I had a passion for architecture, for engineering, and believe it or not, even for the law, because I like to argue. I thought maybe I'd be a good litigator. And like you, didn't have the money or frankly, the stamina. I'm not a parochial type of student. I am an OJT type of student. I need to break things. And that's why I always joke and say I like to break them and put them back together and figure out how to make them better. But the 3D printing, which is as that came up, and I remember those days, I remember reading about them in journals, and once in a while you'd hear about it on the news, this weird thing kind of when it was probably a slow news day.
Yeah, or when Cody Wilson did something stupid.
Yeah, the future of technology kind of stuff. But that was really reserved for the big time geeks. Mm-hmm. And it was always so threatening. And it felt like such a huge learning curve. But that's changing.
It definitely is, right? The cost of printers is coming way down. I think the past few years have been this race to the bottom for price. And sometimes the quality tends to follow it. But other times, yeah, the quality is going to drop a little bit. But you're finding yourself with printers that are $250 to $300 that punch way above their price class. And if you're willing to put a little bit of time and effort to learning how to calibrate them properly, they're going to rival the machines that you see behind me. And for those that are wondering, this is not a fake background. This is actually what my office looks like. Yeah. These printers are about $1,000 on their own, fully assembled. They're about $800 as a kit. Buy the kits. But you don't have to spend that much money to get into this industry. You can seriously do it for a lot less. And Lisa, you're finding this out yourself.
Yeah. Yeah. And you've been a really big help for that as well. And maybe for those who are just joining us and are brand new to this whole thing of 3D printing, I think a lot of inventors, especially new inventors, are hearing a lot about 3D animation. And so, you know, they have this beautiful graphic animated version of what it could be, but it's not quite the same as building it. So what does a 3D printer do? And I know there's two different types, so maybe you can explain briefly just what those are and how they work.
Oh, there are so many. There's over 40 types of 3D printing out there. So I'll stick with the two that most people are going to come in contact with. It's going to be your FDM, fused deposition modeling, otherwise known as your computer-controlled hot glue gun. That's what you see behind me are the computer-controlled hot glue guns. Quite literally, take a hot glue gun, duct tape it to an Etch-a-Sketch, and move it around. That's a 3D printer. There you go. Done.
That's the best explanation I've ever heard because it does. It builds it from the ground up. It's just stacking the plastic on top of itself. So that I've never heard that. I'm going to use that.
Yeah, they're really, really simple when you boil it down, but it's the software that does make them somewhat complicated. We try to demystify that, as you say, on our YouTube channel where literally there's a video premiering right now on the channel where we go through and try to remove some of that BS. And February is the month of resin. The other technology is resin 3D printing. And I'd be remiss if I didn't do my typical resin is toxic because, oh my God, it's toxic. But the quality of part that you can get off a resin printer, you will not get anywhere else under 20 grand. It's not happening. And resin printers you can get for $200. The fact they're that cheap still almost worries me because the chemicals can be a little bit caustic and dangerous. But when you're looking to get something that is, and I am not exaggerating this whatsoever, a perfect example of what would come out of an injection mold, this high detail resin technology is exactly where you want to be. Quite literally, we've printed everything from rings to characters from it. And you can take those rings right to a jeweler and get them cast in any precious metal that you want.
Wow.
Yeah.
That's amazing.
It's kind of ridiculous.
I have hired engineers to help me figure out the CAD, which is computer aided. What is it, drawing or?
It's design. It used to be computer aided drafting, but then everyone just kind of said, we're going to call it computer aided design. Now.
Okay. So it's morphed. So that's what CAD stands for. You get those mechanical drawings, and that's that's the language that speaks to the printers. So you get the engineers to do that and work out all of those specifications, and then hand it off to, in my case, a Proto Labs or a Shapeways or something. But that's getting very expensive compared to what it costs I bought this printer, like I showed a moment ago. That was $189. It's the Endo 3.
Endo 3 V1.
Yeah, exactly. You know your stuff. And I bought that stand. I was so proud of myself off of like Facebook Marketplace for $75 and it's on caster wheels, so I can move it around. It's got the stainless top.
That's a good price for that.
I know.
That's the win out of that whole thing. I thought that was there.
Right in my office, and I can turn, and because it's on wheels, I can pull it up to my desk, and I can sit here and be totally geek out. So it's really fun, and it's possible, and it's a lot less intimidating when you're talking about $189 to learn with versus $1,000 or more. And in fact, back when I really first considered it, the average price for just your basic box was $5,000 to get one. So.
And that's all because of the type of machinery that they're using, right? A proto lab is going to be using a $500,000 machine. Parts have to cost a certain amount. That's why we're not using $500,000 machines. We're using I think our most expensive machine right now is about 90 grand that we have here in the shop. But we try to keep our prices well under what Proto Labs charges, but very competitive, because we recognize that some people don't want to go through that effort. 3D printing is not, as you've learned, for the faint of heart. You got to have the time to really hunker down and learn that tech, because if you're not going to do it, by and large, you're not going to have a good time, right?
Right.
And if that's the kind of person, hey, that's what 3D Musketeers is here for. We're a service bureau. We make parts. So if you already got the CAD, and you don't need anything other than 3D print, send me the CAD file. We can print that, no problem for you. But we do full service as well. And as you've learned, we also love to talk with people where we can help them tune in their printers, because that kind of stuff can be really frustrating.
Yeah. So Kimberly's asking, I'd like to know if it's generally cheaper to do 3D printing or to pay for tooling, to build a mold. FYI, my prototype is 3D printed, but I was told tooling may be better for mass production. Thoughts on that?
Sure. So with that, there's always a break-even point. And one of the things that we pride ourselves here is that we are not going to keep you in 3D printing for any longer than you have to. We're going to run a break-even analysis with you and say, this is where it makes sense. So let's look at what your sales projections are going to be. Let's start selling some 3D printed products. Let's figure out your sales projections and have tooling ready, because at some point you will need to flick that switch. Injection molding is way more affordable than 3D printing. Caveat being that you have to pay for that upfront mold expense. So you're what is called amortizing out that cost. So let's say your mold is $100,000 and you want to sell 100,000 pieces. Every one of those pieces just costs you an extra $1 to produce. Do you have the margins for that? Well, if you're selling a 3D print and you're making money on it already, yes, you have the margins for it. 3D prints are more expensive if you're doing it through a company. Obviously, if you're doing it yourself, you'll need a farm to keep up with most orders. We have 33 printers here as I speak. I'll have 34 end of the month minimum. Yes, end of the month. And that alone is barely enough to do small production runs. We're talking 3,000 pieces will still take us like a week and a half, 2 weeks to do. So you have to look at where your product is going. Don't immediately jump into tooling if you can't afford it, right? Take that time, let it move slowly, let 3D printing do what it's good at. And then when the time comes, go ahead and do that injection mold, because it will save you some cash in the long run. Right on. Took the words out of my mouth. The only thing that I'd add to that, Kimberly, is like at the Invention Accelerator, we talk about in our test module, because there's 5 steps, right? Define, develop, protect, test, and then license. And most people don't do the test. They go straight from protect to license. But if you do decide that you want to test, maybe you're not sure if you want to venture or license, and you kind of want to see it, or you've tried to license and they've said that you need to prove the market demand first. 3D printing is if your product can be made this way. And most of the time it can. It depends on the parts and stuff. And we'll talk. In fact, Grant, I want to come back to that, what you can 3D print. But 3D printing, it can be an excellent way, or any kind of small prototyping that you can easily rinse and repeat to test the market before you go into production. Maybe long-term, it does make sense. Like Grant was saying, with the cost of tooling, that would make sense. But you need to demonstrate for yourself, not just for that company, if you want a license, that there is a big enough demand, because while you hope there is, the reality is it's just a hope, right? So test it, put it on the market, even if it's a break-even proposition or potentially even a loss. Small losses are okay.
Small loss is okay to test your theories. I mean, that's what inventing is. It's all failing fast. We want to know quickly what works and what doesn't. And you can make quick iterations with 3D print that you can't with your tooling most of the time.
Oh,
So,
yeah.
right? Exactly. Let's get it out there. Maybe set a goal of selling 100 or 50 even to get good customer insights, A/B test your pricing, A/B test your different demographics, your different marketing, all of those types of things. And when you've really got that dialed in, then and only then is it time to scale. And scaling means you then going back to licensing or, of course, considering the injection molding or moving into that business model next. So, all right, Grant, before I come back to questions, and feel free to continue to ask your questions in the comments. What is amenable? What's best suited for 3D printing?
That's the thing, right? There's so many technologies across the broad spectrum of 3D printing. Generally speaking, the two limitations that you have when it's coming into 3D printing are your imagination and your budget. I mean, there's everything from $1 million+ metal printers where you can make rocket engines. Yes, that's how the Falcon 9 works. It's got a 3D printed engine that makes it go up. All the way to, couple $100 machines that will make, plastic stuff. So I think the best bet is to look at what does your part encompass. If it is crazy intricate that needs lots of very fine, accurate detail, resin printing or some form of liquid resin printing will be your best bet. If it's something that doesn't need a ton of surface feature where, okay, if it's got some ridging to it, this FDM process would be better for that. If you need something that's strong, you can look at a carbon fiber process or a nylon process. So it comes down to the material sciences as well. And I've really focused heavily on making certain that I'm well educated on all of these subjects so that when people do ask us, well, what's the best material? I can say, well, looking at all of this, it's this. This is what we believe is your best bet. Good example. Oh, God, that's an old video. Oh, man, back when I was still wearing glasses. Here's a good example, right?
Specifically with resin printing, or sorry, is that the right word for this one, resin?
Yeah.
Yeah. Okay. So I look specifically for that type because I know that a lot of people don't know the difference between the extrusion type and the layering on type, like you were talking about with super glue.
Yeah.
So you can explain that difference.
Yeah, it's I can grab a resin printer. Oh, the one that's in the cat bed right there I have it on the floor next to me. We're using it for a couple of prototypes because, oh yeah, I'm an inventor myself. I just open source all my inventions because it's more fun that way for me. I don't want to go through it. I've dealt with enough with the USPTO. I'm PTSD with them. I'm good.
maybe that's where I can help you a little bit. We'll tag team on that stuff.
Maybe, yeah.
Yeah, no, open sourcing it is fabulous. I mean, if we could all just put our ideas out there and we didn't have to make a living doing it, imagine what a world we would live in. Be incredible.
Yeah, I would love that. But of course, there are companies that don't exactly play by those rules. And that's why patents exist. That's why that technology is out there. And, the patents are there for you to be able to protect your ideas and inventions.
So again, I think how would you say that name? Grant?
MJF or Pabon?
Pabon. Okay, Pabon, thank you for your help, Grant. Is MJF good for rapid prototyping, she asks?
It is. So MJF is HP's answer to nylon powder 3D printing. It's called multi-jet fusion. The word kind of makes sense because it's HP, right? So it's got to have a bunch of ink and it's got to have ink heads that lay down ink over nylon powder. It is then heated to the nth degree with crazy amounts of light. And that ink, it's dark, absorbs the light and fuses to the layers of powder below it. It's great for rapid prototyping. The machines are expensive, so the parts tend to be expensive. Great example, we just quoted some parts on MJF versus doing them on FDM. And we saw a 40% reduction in cost by sticking with FDM than MJF. But if the parts are small and you need tons of them, MJF is always the best option as it currently stands.
So when would you choose which type, if someone's considering getting their own printer, what should they consider in terms of differences based on their own invention, which type of printer they should get?
I would say do not start with resin printers. You have to understand what you're getting yourself into with resin, right? It stains everything it touches. It can quite literally melt through your skin if you're not careful. It will kill pets and things. Yeah, don't start with resin printers, please. Some people do, like the mini industry is amazing with resin prints because you can get real crazy tiny detail. But I always recommend to start with FDM. Make sure, you know, that can work. If it can't work, outsource resin for a bit while you get educated. The last thing I want is someone to get a resin printer and end up either hurting themselves or hurting others. And it's accidentally.
Mm-hmm.
But I don't want that to happen. It's why we kind of started this series of resin printing on the YouTube channel, because we want to educate people in that, yes, it is toxic. It can hurt you. But if you treat it appropriately, you'll be totally fine.
So I popped up your YouTube channel if anybody wants to check that out. Guys,
I think I'm supposed to say like and subscribe, right?
Yeah, make sure you like and subscribe. I have, I'll tell you what, and as you can tell already, if you haven't figured this out, Grant has an incredible gift for explaining, reducing it to the ridiculous, you know, helping us understand these kind of fairly big concepts. So you can check out his YouTube channel if you'd like to learn more. You can also go to 3DMusketeers.com/invention-help, as you see here on the screen, if you'd like more information on how they can help you there. Kim asks again, actually, let's go up to this one. Here we go. Grant, can you 3D print flexible, thin printing, and even recyclable plastic?
See, this is where I get to bring out something that I have made for myself for the past few years. For those that don't know, I have a disability. I have 2 herniated discs, and I am forced to walk with a cane. Yes, at 32, it is what it is. Cane handles, this is the original one this cane came with, suck. They're terrible. Throw them away. Ooh, I hit the printer back there. Awesome. This is 3D printed. I designed this live on our YouTube channel, and it is fully open source. It's available online. But I designed it to fit my hand perfectly so that when I'm holding my cane, everything fits. I'm not pronating my wrists. It's as comfortable as things can get. The trick is it's also soft and flexible.
Wow.
Now, the soft, flexible materials are not easily recyclable. However, you can use recycled material. What you see behind me is the blue part back there. I know it's kind of cut off here on the screen, but that is recycled material. But the white pieces next to me over here, those are virgin material, non-recycled. Fully recycled parts as well. And back in the day, we used to do this because it was so expensive to get raw material that we would actually take our failed prints and support material, grind it up, melt it, and then re-extrude it. You don't need to do that anymore. Filament is really affordable. You can get it for like $20 a kilo, made in America. So like, there's no point in doing that anymore, but there are companies that do a lot of recycled materials that we work with.
Awesome. In fact, I had a student write in that was going to try and attend, but he wasn't sure if he'd make it today. And he wanted to know if you can work with just a photo of something close to what you want and print that.
Oh yeah, all the time. I mean, we get everything from the venerable napkin sketch. Quite literally, I've gotten real napkin sketches all the way to full-on CAD, right? And that's why if you go to the link on the website, if you go to the Invention Help page on our website, you can schedule a free consultation with me. I don't even know you do it until it shows up in my calendar. And my lovely assistant, Victoria, goes ahead and schedules everything for you. This is my lovely assistant, Victoria. It's the cat. It's a joke. It's a robot that schedules everything. But you can schedule a free session to talk directly with me where we can walk through some of the issues, some of the things you're dealing with, and make that happen. Because what we tell people, the more information you can give us, the better price we can give you. The more guessing we have to do, the more it's going to cost because it takes more time.
So what would the process be for someone, whether they worked with you or not, if they want to print it themselves or even send it somewhere, whatever? If you have a photo, how do you go from here to part? What is that process?
Calipers, basic design. So we'll use CAD programs like Fusion 360, Inventor, SolidWorks, Onshape, Tinkercad. There's tons of them out there. And we will start drawing that out. If it's something that's more anatomical, say you want to do something like this baby Groot here, this would be done in something like ZBrush. Yes, this is printed. It's in wood filament because you had to do it in wood filament. But you would do this in something like ZBrush or a sculpting program where you're basically playing with digital clay. So it can depend on the type of project, but normally we're doing it inside of CAD. The nice thing about CAD is if something isn't right after the print, or maybe you want something changed, it is lickety split easy to go back and make those changes, reprint a part, and put something in your hands.
Do you often see people needing to go through multiple iterations? They get the first product back. Are they using you to then iterate on that and continue to learn and improve? Or do they usually come to you after it's completely finished and fleshed out and just need the final prototype?
It's a bit of a mix. I much prefer if people come to us in the beginning when they're just getting started. You know, maybe they're in your program and they're looking to get some rapid prototyping done. I love when people come from programs with hardcore inventors that know what they're doing, because then they come with the tech pack, they come with the basic drawings, they know
right
what they need to ask, right? So I don't spend 45 minutes kind of explaining the process. We spend 45 minutes talking about how we can make awesome.
Right on.
But yeah, it can literally be nothing but a napkin sketch, and it does take more time that way, but that's all right.
So if someone is considering working with a 3D printing company, does that usually include if there are extra parts like electronics or extra gadgets or something that need to be assembled in it? Can they count on a company like yours or any 3D printing to do that? Or is that something they have to plan on doing themselves?
You can count on us. I can't obviously speak for our competitors or.
I know like Proto Labs and Shapeways doesn't do that. If I order parts, then I have to sit and assemble all those parts and sometimes sand them down because, you know, they don't come off the printer always exactly right.
Hey, that's a printer tuning problem. That's all I'm saying. Our parts come off. We had someone bring a pair of calipers to a pickup the other day, and he said, I just want to make sure they're right. I said, okay, go ahead. Within 0.02 millimeters, otherwise known as nothing.
That's like invisible to the naked eye.
0.02 millimeters is 1/200th the thickness of a human hair.
Oh, wow.
That's good enough. That's within caliper accuracy. Our parts are good, and we kind of know what we're doing. But yeah, it does come down to finding that right company. We do offer full electronic development in-house as well. So we have our own in-house electrical engineer and programmer. So if you need to do some sort of programming on some custom circuitry, we can do that. I will say, big caveat right now, the supply chains are terrible. And 3 of the 4 electronics projects we have right now are dead stalled because the parts don't exist anymore. And the lead times are currently sitting at 56 to 75 weeks.
Oh my gosh.
I said, we can retool the board and look at new ways to get around this problem, but that incurs design fees. And they said, well, wait. I said, okay. That's the nice thing about inventing. At some point, yes, you want to move fast, but moving fast and moving efficiently are 2 very different things. And if you can't afford a few $1,000s to retool your board, then you're waiting, right? And if you got a patent, wait as long as you need. You got, what, 20 years or so?
Yeah, if it's issued. If it's issued, then it's 20 years from when you applied on a utility application.
Right.
But a lot of inventors mostly work with a provisional patent application. And the goal is, once you file your PPA, to get it out in front of companies and get it licensed before that expiration date, so you can use the earnings from that to either finance the utility application, or if there isn't any money, at least you know it's worth the investment to move forward with utility after that point. So yeah, that rapid iteration, fail fast, fail forward, all of these concepts that we talk about in large organizations, that doesn't seem to translate for some reason as much in our communities as it should be explained, is such an important part of the process. Because if you haven't, until you've actually built it, it's all theory.
Yep. So I'm giving a talk this weekend at Grow Pasco, and it's all about the invention roadmap to success. And my opening statement is, your ideas are worthless.
How nice.
Unless you execute. Because this is not the .com bubble of the early 2000s. And yes, we are in a resurgence of inventing right now. But no one's going to pay you millions of dollars for your idea unless you can execute on it. Generally speaking, you might get lucky. And if you get lucky, hey, hit us up, right? But generally speaking, you have to have something to prove that you can do this. right? Yes. If Warren Buffett says, I'm looking for investors, every single person on the planet would be a moron not to toss him a couple of bucks. The man's been great with this.
Right.
But if Grant Posner goes and says, I'm looking to raise $10 billion for my next great invention, they're going to say, and who the hell are you?
Exactly. But if you can demonstrate that you've solved a problem dramatically better than all of the competition and given me a reason to believe that it really will get the job done, because if it's truly a wow product, my first question is, yeah, but does it really work? I mean, in theory, that's great, but can it really get that job done?
Exactly.
And a demonstration, I'm going through all this with my mop, as you know now. That's a subject for another day. Okay, let's take another question here. I have a kitchen barbecue. This is from a LinkedIn user. I have a kitchen barbecue butter application item that 2 companies are interested in, but they are both requesting working prototypes, and all I have are good quality 3D drawings on the items. They suggest I get with a local 3D plastic printing place to get those 2 small items made up. It will need to be made out of food grade plastic. 2 questions. 1, how detailed do the drawings need to be? And 2, will you sign NDAs? Thanks for your question, Chad.
So, Chad, 1, there's not a lot of great food grade plastics out there. This technology, FDM, is not food grade, period. I don't care what the manufacturers tell you, they're lying. It cannot go through an autoclave, it cannot be sterilized, and therefore it is not food grade. If the raw material is food grade and your printer is food grade, that's fine. You can use it once, then you have to throw it away. It's like disposable plasticware. Definitely never printed a fork when we ran out of forks that one time in the business. So what we would say is, for your prototype, I don't think it needs to be food grade to show its value. No one's going to likely eat the product when you're showing it in something like this. We work with quite a few large food packaging companies, and we make their prototypes on these printers directly behind me, and it's totally fine. They put product in it, they verify it works, then that product unfortunately goes into the trash because it is not safe for human consumption. As far as NDAs, not only do we sign NDAs, I have a pre-signed NDA right on our website that you can sign without ever meeting with me. If you don't meet with us within 72 hours, I null and void that, because why? But yes, you can go sign our NDA. We do not accept outside NDAs. I've spent more time and money than I care to admit on that NDA, and I'm very comfortable with the way that it is. I will say, if you do choose not to use an NDA, we do have some really cool marketing stuff that we do here. This printer directly behind me is currently time-lapsing. We do them twice a week on our YouTube channel. So if you want to get some free advertising for your product, or if you want to use it in marketing, NDAs would keep us from doing that, but we have that availability to do something like that, where most other companies don't.
That's super cool. So explain the time-lapsing before I come back to our questions. What does that mean? How does that help someone who wants to market?
If you want to show how your product is made to people that are interested in it, that's a great way to show it, especially to investors. It's more like a wow factor than anything. You just kind of see it being built out of damn near nothing. It's a cool process. A lot of it is just for show. We do it to show off on social media, the kind of cool stuff that we're making. But it is and has been helpful to others in the past when they are looking to raise money.
I actually do have let's see here. I'm going to share. I did pull one of those up, and it's super cool to watch. So I'll share that with you. Hit play.
Yep.
There we go.
This was yesterday's time lapse.
Yep. Isn't that cool? So that, as you can see, folks, it just is building layer on top of layer is the way that it prints. Of course, it's not showing the printer going back and forth and how that works.
Correct. The printer parks out of the way for those photos.
It's so cool. Love it.
I'll give you a bit of trickery. Those 2 prints were done separately, and they were edited together because there's no purge block or anything to do dual color. Is Snake behind me? Where's Snake?
That's really cool.
Oh yeah, he's behind me. I can't reach him right now, but he's back there. But yeah, so that's part of what we do here. We offer that for no additional cost, because then I get to put it on social media too. There's one less piece I have to print. Right. But yeah, we are no stranger to NDAs, as are most prototyping companies. If people refuse to sign NDAs, you should maybe look at what they're doing. But if you do have a patent or at least a PPA, NDAs are not always worth the paper they're written.
Not as critical at that point. Yeah. Right. Yeah. Because it's first to patent anyway. So someone's filed, they've established that priority date. Unless there's a reason, and sometimes there is a legal reason to keep it confidential. And if that's the case, you'll definitely want everyone to sign an NDA.
Absolutely. And that's why we have it on our website. It's so much easier than this whole dancing of who has a better NDA. It's like, look, here's mine. It's pre-signed. Just sign it. Thanks. It makes life a lot easier.
Keeping it easy.
We're no BS operators here, right? I want to cut through the BS. I'm not going to sugarcoat things for people. If you want someone that's going to blow smoke up your ass, you can go find other companies. We are here to make awesome. That's what we do. And that's why we do it, right? I'm a business guy, right? Literally 2 business degrees. I don't want people just to like say, oh, well, your idea is amazing. It's going to make the best. Pay us 20 grand and we maybe potentially help you make things happen. No, that's not how this works.
All right. So Stefan is asking, hi, Grant. Thanks for bringing us up to date. I'm using how do you say that, Grant?
Cindo
3D WOX. It's easy and good for hollow PLA, but not for anything else. Is that still a good machine, or should I be shopping for something else?
If you are looking just to stay with PLA prototypes and you've got it running well, hey, keep running it, right? My preference is always a Prusa printer from Prusa 3D, shop.prusa3d.com. They don't pay me to say that. I wish they would. Because we definitely sold hundreds of their machines. What is behind me are all Prusa printers. When we need to go to client meetings and I need to take a printer with me, I'll grab one of the ones off the shelf behind me, huck it into my car, drive it to where I need to go, huck it on a table, and click print. There is no calibration. It auto bed levels. It detects everything from skip layers to filament jams. It is so good. They just work. The print that's going here on this back printer is about 19 hours. I started it earlier today and I'm going to leave it alone. I'm not going to touch it. It finished parts. Oh, they're in the bins. Can Grant show the bins?
Sure.
Yes, they're in the bins right there. They're in that bin. That's where those other parts are because we did them for time lapses. But yeah, if it works, don't change it. But if you're looking for something better that can produce better parts, you have to ask yourself, how much money do you have to spend? If you've got $1,000 to spend, the Prusa printers are great. I always recommend the kits. And you might say, but Grant, I'm not all that technically inclined. That's fine. It's going to take you about 11 hours to build your first Prusa Mark IIIs. But the instructions are so good that it comes with a bag of gummy bears. Okay, cool, gummy bears. But it tells you throughout the build process to stop, have a specified amount of gummy bears, and then continue.
Oh my God.
Yeah.
That's awesome. Deb, I love your question. It was actually on my list. How long does it take to make a prototype of a product? And do you manufacture as well, Grant?
Yeah, those questions are always tough because the answer is it depends.
But it's everybody's question, right?
It's everybody's question. It's either that or from a 30-second conversation, can you tell me how much it's going to cost to make my product? Yeah. The answer is always, it depends. We've literally had parts as low as $5 and as high as $50,000. We've made parts from the Smithsonian to Snoop Dogg and everybody in between. It always depends. We say on average, an invention that comes through us is going to be at least about $1,000 to $1,500 by the time you're all done. Some of them cost a lot more. Some of them cost a lot less. It depends. As far as manufacturing, we can do short run manufacturing for you. If it does make sense to 3D print it constantly, yes, we can do that for you. But we have relationships with injection molding facilities here in Florida. One of them is particularly veteran owned. I like the guy. He lets me go down and play with the machines when I'm in the area. So anyone that lets me come into their workshop and push buttons, I'm always happy with this. But it's another small business, and we trade work back and forth because he's the guy that you go to when you're looking at 15,000 and above. When you're looking at 15,000 and below, generally speaking, 3D printing is the better option. But that's what the break-even analysis is there for. Once you have your CAD ready to go for production, we'll give you a price for the 3D printing. We'll go to our buddy and say, hey, what is this going to cost for injection molding? He'll give you the price per part plus the mold cost. We present it to you. We run a break-even analysis and we figure out when does it make sense to make that switch if it ever does.
So can you grab the wood, the part that you just showed that you made out of wood, plastic? Yeah. All right. So how long does a printer take to print something that size?
So it's like 14 hours. It's about 7 inches tall or so.
Mm-hmm. And out of a standard PLA, what would a part like that cost somebody, one of your customers?
Cost customers or raw material costs?
Your customer.
This would be about 150.
Okay. I think that is a really good benchmark for someone to kind of guesstimate. And if you did need to assemble parts afterwards to print them, you would either do that or outsource that for inventors as well?
Yeah, so we do full part assembly as well if it's something you needed to do. So let's say there's circuit boards and stuff, we can put all that stuff together. It's nice and easy. If you need it where, parts are coming in from different factories and all that, there are houses that can do that easily for you. We have some of those under our umbrella, but it's not often that we find people where our own capabilities do not meet their needs.
Sure. And I understand that takes 14 hours to print, but that's not the same thing as turnaround time. So how long would someone expect something like that to turn around on average? I know that it depends on your backlog.
Yeah, it depends on how busy we are. We say
these days, like right now, if someone came to you, what would that take?
We could probably have it done in 3 days.
A few days.
Normal turnaround time is 3 to 4 days.
Okay.
For some big parts, they're going to take longer. For example, this print right here, that is a 22-hour print on its own. And I need to do 4 of those for the client. So they're not getting done in 3 days because it's more than 3 days of printing. We could separate it across multiple machines and get it done faster. However, those are for X-ray machines. And if we do them all on the same machine, any tolerance issues that we have are consistent from part to part to part.
So you know how to, makes sense.
Exactly. And that is the printer they always get their parts made on. So everything is tuned directly for that one printer.
Oh, that makes sense.
Yeah.
So Stefan is asking, can you print parts that are part elastic and part stiff?
We can. It is not the easiest. There are some technologies that can do it. PolyJet is one of them, where you can use a stiff material and then a soft material, and you can vary your durometer, which is the flexibility of everything. However, we generally prefer not to do that. PolyJet is crazy expensive. The machines start at 50 grand. And that's for one that can't do what you're asking. The ones that can do what you're asking are about 120 to 160,000 base price. And that's just 2 separate materials. So we try not to do that when we can avoid it. If it can be done in separate parts and then chemically bonded together later on, that lets it happen and get into your hands for less.
Perfect. Kimberly's asking about the NDA and where to find it. So Kim, I just put the banner back up. It's 3dmusketeers.com/invention-help. And if you scroll down the page just a little bit, you'll see a big orange button that says view our mutual non-disclosure agreement.
Yep. And I see Pabon and my brother's Jonathan Posner.
Oh, nice.
We're identical twins, which is only funnier of the fact that we have a 3D printing business making copies for people. It's just my whole life is a joke.
You need one more to be the official 3D Musketeers.
There were 3 of us that started it. That's where the name came from.
I think it was Kim earlier said she loves the name of your business.
That was all my dad. And if you want to learn about that, we actually interviewed my dad for Father's Day last year. It's an episode of our podcast. It's like a 2-hour roast session. It is so much fun. He's the one doing most of the roasting, though. It's a great way to kind of learn more about me as a person than the businessman, right?
Well, you know what? It's always good to get to know the people that you're going to work with, especially if you're going to build a long-term relationship. We have so many more choices than we ever have because of the global connection that we have now that we didn't have just 5-10 years ago. It was available, but we didn't use it. And now with Zoom and these types of things, man, there's anything that we can do.
Yeah, we've never met in person.
No, I feel like we have. In fact, I feel like we go way back too.
Well, and that's what we like to do, right? Like I have customers from years ago that are my good friends. They come out here. They have a friend of theirs that's going through some medical stuff here in Tampa. And every time they're in town, we try to get together. We hang out. We just exchanged Christmas gifts a couple of days ago. And we made their wedding cake toppers 6 years ago. Aww. And they just become really good friends, and we go hang out with them. They're my place to go hang out on the other coast of Florida, which is only 2 hours away.
Are you saying that they drew their own custom wedding topper and had you print it for their wedding? That is such a cool idea. Was it with their faces instead and everything? Is that how they did it?
This one was not. So this one just said love you more, and it had the date on it. They wanted something very, very simple. They were having a very low key wedding, but we've done some crazy weddings. The the one that will always stick in my head is Christina and Aaron Pabon. They're good friends as well, and I always love shouting them out. It was a Doctor Who and Superman themed wedding. They wanted to maintain that the bride and groom would not see each other in their outfits until the day of the wedding, so there were 6 total 3D scans that went into making this happen. She is pulling him into a TARDIS as he is ripping open his tuxedo to expose the Superman logo.
Oh my God, that's
and
so cool.
That is their wedding cake topper.
Good for them.
It was so much fun. The entire bridal and groomsmen, the bridesmaids and groomsmen came the day of the wedding to pick it up. We had it pre-boxed and ready to go. They opened it, made sure it was good, and they took it and they snuck it in on top of the cake. We've got photos from that event. Hilarious. I have a copy of the part, and I always make fun of him. I'll send him photos, said, "Hey, you're in my car today. I threw you in the trunk."
That is super cool.
And like, that's, I believe if you,
sky's the limit.
If you can't be friends with people as part of the business, then what's really the point? I feel like every person that we work with I put a part of my soul into it, right? Where I'm treating your project and our staff treat your projects as if they're our own. Because if we don't do that, then what are we really doing here, right? We're just kind of, we don't want to just like do the dance moves the way the book says. We want to add a little flair to it, if you will, and try to make some recommendations that maybe you didn't think of.
You know what? I would really like to dig into that a little bit more, but let me get Stefan's question answered here. What are the maximum dimensions for printing a part?
Single print dimensions, the maximum that we have available currently today, this is changing, is 16 by 16 by 31 inches, or for all of you metric folks, it's 400 by 400 by 788 millimeters. To give you an idea, the printers behind me are 250 by 210 by 210, or 9 by 8 by 8 inches. So it's a big damn machine.
And can someone, if someone wants to make something bigger, can you help them with recommending how it might be split into parts and assembled instead?
We take care of all of that. So we have chemical welding agents that will bond the parts so well, it'll be stronger than the actual 3D printing itself.
Wow.
It's a chemical bonding agent. It's a lot of fun. We'll do things like add metal rods into the parts. So there's keyways. We've used carbon fiber. We've used wooden dowels. Hilariously, are a great way to do it, because if the hole isn't perfectly sized, just sand the piece of wood down till it fits. And of course, when you get wood wet with glue, it expands a little bit and just basically becomes impossible to remove.
Wow. Yeah. Well, that answered actually the other question that I was going to ask you. Let's talk a little bit about scanning, because sure. I think that's going to lower the bar for those of us who don't know CAD or don't want to become proficient in it, maybe just know enough to be dangerous like me. How is 3D scanning helping and influencing the industry?
It's amazing. There is nothing quite like taking a scanner, walking it across something a few times, cleaning up the model in CAD, and that's a little bit of, magic there, obviously, and then printing it out and putting it in somebody's hand. There is nothing quite like this is what I brought you, this is what I got. And it's really cool. We have 2 high-end 3D scanners here. We have a whole page on the website to talk about that as well. We have an Artec Ray and an Artec Eva. The Ray is probably not useful for most inventors. It's good to 110 meters. Like, you can put it in the middle of a football stadium and scan the entire stadium in one scan, which is kind of crazy when you put that into perspective. Then the Eva, which is a tiny little handheld scanner. It's about the size of a hand mixer. It's my most expensive hand mixer. They're $20,000. But they're capable of getting accuracy down to 0.1 millimeter, which is generally good enough for most people.
That's amazing. So Andrew had asked the question earlier about taking just a photo and being able to 3D print that. Obviously, it has to be converted to CAD. Which do you think is a better process, to actually just buy that product and scan it and then 3D print it, or building it from scratch from CAD based on the photo?
It kind of depends, right? If you don't mind some of the inaccuracies of 3D scanning is great. But 3D scanning is only good if you're looking to copy something. If you're looking to make some changes to it, 3D scanning gets complicated very quickly. What we will use 3D scanning for often is to get a general idea of what the part looks like, and then we can quickly build it out in CAD. So small details that would be a real pain to get with a pair of calipers, we can easily pick up the scanner, measure it, and then design it out inside of CAD. So I think they really go hand in hand more often. But one of the big business models that we did prior to everything occurring in the world was we used to scan people and 3D print them. And that's where 3D scanning is amazing. I can take you as you stand and turn you into an NFT or put you in the metaverse or whatever things the people much smarter and wealthier than you are saying.
I know.
It feels like tax evasion, but apparently it's not. But yeah, the scanning technology is pretty amazing. We displayed it for the first time publicly last week at Synapse Summit here in Florida. And it was a hell of an event. I've never stood that long in the past few years. And with a bad back, it was very painful. But it was so awesome to see. Like, we put the scanner in the hands of a lieutenant colonel with the U.S. Air Force who had never seen this technology before. And he just did it. Just scanned something right then and there. And you could see his mind was just progressively being blown over and over and over again. He said, I have been in the Air Force for over 20 years. I have never seen something this cool.
That's cool. So
that's kind of cool, right?
So a scanner makes sense if you're going to print an exact or as close as possible replica. But if you wanted to edit that file once it's been scanned in, it gets very complicated, I assume, in how that translates to the software, like Fusion 360 or whatever.
Yeah, Fusion would just kind of implode on itself if you tried to load this in. You would have to go into more of a sculpting program. There are scanners out there that can go directly into CAD programs, and I am trying to get ones for review. We'll see how successful that is, right? Trying to use that influencer clout with the YouTube channel to get some of these scanners.
Oh, man.
Like, if someone's going to drop 5 figures on a 3D scanner, I want them to know what this market looks like and whether or not they should be going with one company over another, because nobody's done this before.
All right. So this is why y'all need to go subscribe to his channel to help increase his influencer credibility so he can get his hands on this stuff and tell us all about it for free, which is awesome. I noticed on one of your videos that you had one that you had scanned, I think it was for a court case where a car had been in an accident. There it is.
This is one of them, but yes.
You had, now that's what the car actually looks like.
This was the actual vehicle.
That's not a mistake that 3D printer made.
So I realized at Synapse, so many people thought these were failures. I'm like, crap. I thought it was kind of obvious. People are like, why does your part look so bad?
All messed up.
Because the car looked this bad. Yes, okay. The bottom of it is not real. I definitely put all of our contact info on it. And I sliced it flat because it's the bottom of the car. They don't, in this particular instance, they were not too concerned with the bottom of the car. It looked like they were more concerned about this whole area of the vehicle. But yes, this is an actual car that that was scanned for an actual court case.
It's amazing. I wonder why, maybe you know, maybe you don't, but why they would think a 3D printed version of that demolished car would be any more effective at communicating or making their point, their case, than photographs. What do you think?
Picture's worth 1,000 words. How much is it worth to put the model in the hands of the opposing counsel or show it to the jury? You can't bring the car into court. No one's doing that. That would be very much a look at how amazing I am to drag a crash car to court. But pictures can only tell so much of the story. If I want to see really where the driver ended up, sure, I can take a photo and show you this, or I can say the driver ended up right there. Can you imagine being all bent up in that seat? What kind of damage that would cause to your body? Lawyers speak, lawyers speak, lawyers speak.
Yeah, right? Yeah, exactly. Yeah. Do you happen to know how that court case turned out?
We don't get to know that. So we make the parts. I know the docket, so I can go search for the docket, but that one in particular is not one that I really want to know the outcome of. There was a loss of life involved in that particular case.
Yeah, I understand.
That kind of stuff. And I don't have it on me because it's still in my box of stuff, but we did one for an insurance company. It's not common we do them for the insurance companies, where the insurance company thought that the person was being reckless and stupid, and that's how they got hurt. Lo and behold, they were being reckless and stupid. And it saved the insurance company over $4 million.
Wow.
Yeah, right, that's a real number.
We're coming up on the end of our hour in just a few more minutes here. So drop your questions in if you want to get them answered before we wrap up. Keep in mind that there's a little bit of a time delay. So hurry up and get those in there for me. Grant, the reason I asked that question, yes, I was going somewhere with it.
That's okay.
So I'm very, very sneaky that way, is because there's this big debate in the invention community about whether or not you really need a prototype. And I feel like you just made my argument for me. And that is, it's one thing to show someone a picture, and then it's even better when you show them an animation. But it's always going to be better than that when you can hand someone a working proof of concept, even if it's not food grade, right?
Right.
And I saw earlier, one of our comments was from someone who's using a 3D printer to make prints for puppets that go with her book, which is such a cool idea. And interactivity, it's just engaging, storytelling. It's more memorable when it's a story that people can remember, but it's even more powerful and impactful when they touch it, feel it, test it. So that's why I'm a strong believer in it. And historically, it's not been something that most people could afford to do.
Right.
And
that's what this democratization of the industry has showed us, right? 3D printing's been around longer than I've been alive. It was first patented the patent was filed in 1982. It was granted in 1984 to Chuck Hull over the resin 3D printing process, stereolithography specifically, if we want to get very specific about it. Chuck Hull now is on the board for 3D Systems, one of the largest 3D printing companies in the world. They make machines. They do some in-house printing, but not much anymore. They make the printers. Now that these patents are starting to expire, that's why we're seeing this democratization starting to exist. Yeah.
Well, that makes a lot of sense. Yeah. And those economies of scale, of course, bring the cost down to us. I'd love to hear your closing thoughts on what best practices in terms of software. You know, we talk about Cura, we talked about a little bit about Fusion 360 today, but for someone who just wants to get into this, where should they go and how should they get started beyond starting with your channel?
Oh, you knew I was going to.
I knew you were going to go there. Yep, because I'm going to pop it up. So in addition to checking out 3DMusketeers on YouTube.
Yeah.
What kind of software do you recommend? And if a printer, which one would you recommend people get started with?
If you are not technologically savvy, start with Tinkercad. I know it says CAD in the name. It's not CAD. It's like building in Minecraft. It is so abysmally simple. I have quite literally taught it to 5-year-olds. Their tutorial is amazing. It's by Autodesk, the same company that makes Fusion 360. So the movement from Tinkercad to Fusion can be pretty easy. We do recommend eventually that you move into a program like Fusion 360. It is legally free for makers and startups. And if you do eventually have to pay, it's $500 or less a year. It's not that bad when you're a big business to pay for it. Yes, it's money, but SolidWorks is $4,000 a year and doesn't have a free tier. So you take that for whatever you want it to be worth.
Exactly.
As far as printers, we've done a rundown of kind of, some of the cheap printers out there that I like. I like the Prusa Mini. It's about $500 delivered. I think that printer is a good value to the point where I raced to build one with my girlfriend, who is an ICU nurse, someone who is technical, but not technical in the way that I'm technical, right? And we raced live on YouTube, and we were within 10 minutes of each other for how quickly we got these things done. And that's how good the instructions are. You can actually watch us build it live. There's a 46-minute video of the build. And that printer's good if you're on a budget. If you're on even tighter of a budget, the Ender 3V1 like you have, or my preference, the Ender 3V2 is another good machine to have. They're more complicated because they don't do auto bed leveling. They don't have an all metal hot end, and the support from Creality is all but non-existent.
Yeah.
And the community support is, it depends, right? Some people know what they're doing, but some people will think they know what they're doing, comment, and send you down the complete wrong rabbit hole. That's why we do Print Fix Friday on the YouTube channel. So if you are doing 3D printing, you are having problems, email us. You can tag us on all the social media so I can see it. And I will analyze it and break it down every Friday we do them. And I think that's what we do to help out newbies that are looking to get into the industry. If you do have the cash, though, the Prusa Mark 3S or whatever its new successor is going to be, we're expecting an announcement sometime Q3, Q4 of this year for the successor to the Mark 3S. I have 8 of them. They are workhorses, and I love them. I trust my Prusa printers quite literally with my entire business.
Love it.
They work.
Oh, there's a big learning curve in understanding the software, and then you've got to understand all of the different technicalities of what's working, what's not. Is your bed level, like you mentioned, how hot is the tip, whatever, which plastics to use, materials, all of that stuff. So outsourcing something like that, and maybe getting something that you can continue to work on and grow and develop your own skills along the way might make sense. If you want to make this your career and you're going to invent a lot of products, then there's going to be a lot of iterations of parts that you'll need to go through. And so over the long run, some combination might even make sense.
Yep.
But I would encourage anybody considering getting into the business of becoming a professional inventor to at least talk with Grant or someone like Grant and get the skinny on what's going to work for your parts going forward.
Don't be afraid to iterate. Seriously, if you're afraid to iterate, inventing may not be the right course of action for you.
Definitely not.
You want to iterate in the prototyping stage well before you're spending 30 grand to fix a mistake. We interviewed Chun Ung, the rainbow loom inventor, and he talked about making a mistake like that cost him $100,000.
Oh my gosh.
Yeah.
That cost a lot more than my $189 printer. So I'd rather go through many iterations figuring stuff out. And then when it's above my pay grade or I don't have time, I'd rather just outsource it. So,
amen to that.
Or while I'm learning, for sure. Thank you, Grant, so much. We're getting lots of people love the show today, getting great feedback and comments. I've listed, Deb, you asked for an email address, info@3dmusketeers.com, or you can go to 3dmusketeers.com/inventor-help to get that NDA if you'd like to talk more with Grant about how they can help you. In addition to any other questions you might have about 3D printing, make sure you check out his YouTube channel. So that brings us to the end of our show today. If you missed any part of our show or just want to go back and watch the show again, you can catch the replay right here on Facebook or LinkedIn, wherever you're visiting from today, or you can listen to Inventing on all major podcast platforms like iHeart, Pandora, and Spotify, starting at the end of this month, February, so March 1st. And please help us get the word out, folks. If you like what you learn here today, we do this every single Wednesday. You can share the pre-recorded or post our future videos. And of course, as always, you can go to theinventionaccelerator.com to book a free coaching call with me. I hope you all had a great time today. I know I had a lot of fun. I want to talk to you for hours about this stuff.
Well, you're going to be on our podcast in a couple of weeks, so it's going to be a lot of fun. We're going to be talking about your story, not so much mine, coming up in a few weeks.
Exactly. Looking forward to it. Awesome. And yes, Deb says, come again, Grant. I'm going to have you back as many times as you'll let me.
Hey, if there's one thing that I'm good at, it's talking. My dad always said I had a face for radio. He never thought that I actually have a YouTube channel and a podcast. So whenever you want someone to come on and just talk shop, have fun, I am your guy. Always, awesome. Please hit me up. I love this kind of stuff.
Sounds good. Thank you. And thank you, everybody, for joining us. Have a wonderful rest of your week.
Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. I have to do the YouTube outro, right?
That's good.